And hello, everybody. We're about to begin this course, this very course DP 203 for data engineering in Azure. My name is Crux Perez, and I'd like to welcome you. And thank you very much for your time here. And I hope you're gonna enjoy this course and prepare for those who are pretending to pass the exam. And well, no secrets here, lots of things to see. And we will basically have here first on this very first day a quick overview of the whole agenda and right jumping into the first modules. There are like about 11 modules to check, to see during this course. And before that, I see you guys are quite a lot, bunch of people here. Good, good. And I always like to actually know a bit more about my students in my course. So about me, first of all, I'm living actually in Mexico. Um, on the very nice part here on the currency. And I'd like to know more, to know a bit more about you. Um, as I told you, living here, but I was as a business analyst in the IT industry, and I was very passionate by data, right? I've worked within data about like 5, 6 years now, and being as data analyst, data engineer, and I had this opportunity to pass this exam. So now I'd like to share my knowledge with you and try to, well, give you some idea about what means being a data engineer within the ecosystem of Microsoft Azure, right? Please tell me about your maybe background, a bit quick, let's say, some quick background on the chat so I can know you a bit better. What are your expectations, maybe? Where you're living? So that would be good. And I'm always curious about uh, who are actually following those courses, who are taking those courses. In the meantime, I will start to present you the content of this course, since we have a lot to on our plate here to learn. And yeah, so the rules are very simple here. Okay, whenever you have a question, please, my wing partners here, Brianna, will definitely answer your questions, your doubts. So please, do not hesitate to ask any question you have. You're gonna have access either to the lab, right? This is very important for practicing. And on the first modules, I will not go into demos so much because you're going to have anyway the opportunity to do that in the lab. And as I said already, yeah, a lot in our plate to see. So I'm going to give you the very theoretical part here so you know a bit more what's, let's say, the high level stuff and what it is about. So I'm not pretending here to read all of these texts you can see here about this course. Just, all right, people, just so you know that this course is done really for anybody that are interested in data engineering, right? And well, what is very important here is about analytical solutions that I would try to give. We're going to see lots of technology, like you can see here, Apache Spark within the Azure ecosystem, going to be familiarized with Databricks, for instance, and very big and especially very useful tool, Synapse. And Synapse has lots of things like pipelines, SQL pool, etc. All right. So yeah, you will be in touch definitely with lots of technologies here, and that's what is important for you guys to get in the mindset of, first of all, as I always recommend, get the high level, and then we're gonna go deeper and deeper and deeper, little by little. All right. So that's my approach here. The agenda is explained here, right? So the first module, since here it's just the presentation, a quick intro. Here, first module, we're gonna talk about what actually what makes, or what a data engineer use a lot in his day-to-day, let's say, tasks. There's one very big tool, as I already mentioned, Azure Synapse. That's the first thing we're gonna see together, followed by Azure Databricks. And then you're gonna actually see what are the, let's say, solution about storage. And using data lake is very fundamental for us as a data engineer. And one thing that is appearing more and more, what is used more and more, is data lake. The data lake is a quite particular architecture, right? It is not a service, as many are actually thinking, but we're gonna get into that anyway. So that's gonna be in the first module when we're gonna check out the compute and storage option you're gonna have at your disposal, people. Then the second module is about how we're gonna actually dive into created solution, a platform for many capabilities that you are looking for. Create metadata is something we're gonna also check out in the second module. This is gonna be today, right? The first and second module in this very morning, as where I'm talking here in this time zone. The security is always fundamental. Okay, very fundamental. So the third module will be about exploration and transformation, and that's in Databricks. Okay, Databricks is a very useful tool when you are talking about the data science. Data science, when you want to get out the forecasting, predictive analytics. So that's where we're gonna try to see here in third module, read and write data, work with data frames, which is very important here. Also a concept from a library you're gonna use within Databricks. Finally, how use some advanced methods. Okay, that's the third module. Then it's gonna be followed by the module 4 and 5. And I'm going quickly to those. I'm gonna explore something very common, and it should actually ring some bells. ETL process, which is a very common within the data engineering world, because what you are going to want to do is building a data warehouse, and Azure Synapse is very good. And actually, Apache Spark is also available within Azure Synapse. That's all those things within ETL, Azure Synapse, Apache Spark, we're going to see in Module 4. Module 5, we're going to see how to ingest and load those data into the data warehouse. So again, it's going to be with Synapse Analytics. And we will also have a look about Azure Data Factory or the Azure Synapse pipelines. Okay, I can see here. Yeah, not audible. All right, so I'm gonna wait a bit before going on. I hope now it's better. Let's see. Okay, I guess now you have here my screen. I hope this is better audible. The audio is better. Okay. Maybe I'm gonna try to speak a bit slower so the lagging would not be so big. Okay, so following up, Module 6 and Module 7, transform data. So again, this is the next step with ETL processes. And Module 7 is about orchestrating data movement. And again, this is about, okay, I can see here some feedbacks about the voice. Okay, and that's, yeah. Okay, I will try to maybe later on. Perfect. Okay, hopefully the connection would be a bit better. Okay, so some people here have got some problems with the connection, so let me check. Here it appears we have good lagging. Okay. All right. So that would be the module 6 and 7. And module 8 and 9, end-to-end security with Azure Synapse Analytics. So that's about here the security within Azure Synapse, because security is always key. Yeah, it's a key thing. It's a requirement that has to be handled very carefully. And within the Azure ecosystem, the security has been held in a very, let's say, efficient manner, should I say. We're going to talk about data health security. Here we're going to talk about a bit more Azure Key Vault, and we're going to definitely talk about compliance, sensitive data. Module 9, we're going to overview the hybrid transactional and analytic within Synapse. And in there, Synapse Link will allow us to support these hybrid transaction analytical. Just to give you here, let's say, an understanding, it's when you need to work within those both contexts, transactional and analytical context, right? So over there, we will see any subject about that. And finally, we will end up with this course talking about real-time stream processing within Azure Stream Analytics. And finally, how to create a stream processing solution with the Event Ops and Azure Data Lake. Right, here is just a little, let's say, view about who are the principal audience. Are you here? Are you here on the right course? Yes, definitely. If you are about to check out how to work within the business intelligence domain, and if you want to get more knowledge about the Microsoft Azure data engineering, right? If you're looking for solutions about storage and analytical solutions, that course is definitely for you, okay? And if you're a data engineer or data analyst. All right. I can see here a very issues about the connection. Let me just try something here. Okay, let me try to fix that connection issue. All right, just be back, people, in 2 minutes, right? From I'm gonna start my router. So I guess it's gonna be better. All right. So just a bit of your patience. Thank you very much. So, okay, here we go. Now you should see my screen. Perfect. Now, okay, guys, sorry for this delay since the, well, I guess the bandwidth was not so good, but now it should be better. So, I'm gonna take back where I just left you guys. Um, Now, that's what just a quick introductions for this course, all right? So the prerequisites are that you definitely into the data engineering field here, or at least look for some solutions, right? For getting into, well, getting actually better in your data architecture, or maybe also to support any big data, let's say, tasks or data warehousing, because all the infrastructure will depend, and as I would say, the efficiency and the performance is actually, yeah, it depends or it relies on the architecture and therefore all the data engineering tasks you may perform within your organization. All right, so without any further ado, later on you're gonna have some lab, right, to practice and see how actually it takes place. So from now on, let's begin with the first module. Um, Let me just put it here. Second. And I will. So the first module would be exploring compute and storage options for data engineering workload. The agenda for this first module is quite pretty straightforward. We're going to have an introduction about the Azure Synapse Analytics, which is a very, very central component in your architecture, because as we're going to see, Synapse is a kind of one-stop shop, in the sense you can do many, many things. And if you harness this tool, you will be actually very, very, you will have here very strong, let's say, strong position when you would like to integrate whether in an architecture already, in an existing architecture within your organization, or you'd like to build from scratch something. So Azure Synapse is a very, very important here, central tool. Then we're gonna describe quickly Azure Databricks, and that's really useful when you're working with data scientists and doing some machine learning things. We're gonna introduce you here what about the storage option, especially with the data lake. What is a data lake architecture? And finally, how to work with data streams using Azure Stream Analytics. So let's go on with the first lesson here, introduce you Synapse. Synapse is a very great tool. As I said, once stops shop when you consider to get from scratch a complete architecture within your data engineering, especially if you are working with, for instance, different factors. For instance, here is a quite, let's say, description, a high-level description about what is Synapse Analytics. I should say the most important thing you should take out from this is that you're going to have here SQL pools and Spark pools. Okay, those are concepts that are very, very recurrent within this course, because that allows you to actually build what we call a data warehouse. Okay, you can build data warehouse. Data warehouses are, remember, if you in this concept yet, it's, let's say, a story, a way of storing your data so you can do analytics. And usually what the best practices recommend us is to do, for instance, the star schema in your with your tables, because that's the best way for being efficient in process your analytical things. So you have a fact table, dimension table, and this is what your data warehouse will be. And this is what basically your SQL pools will handle, right? Whether it is dedicated or serverless. And we're gonna actually see what a serverless SQL pools can do for us, okay? And a Spark pool. Spark is a technology we're gonna also talk about a lot within this course, and it has been built by Apache, an open source organization that Microsoft is leveraging because we want to be familiarized with technology already in place. Microsoft is not intending to create some new technology, a niche technology where you need to relearn everything, but already coming from what is known. And Spark, for instance, is something that you should remember working with big data, big data analytics. So that's another part of Synapse. First thing, data warehouse. If you need a very huge and complex data warehouse, you can use Synapse Analytics. You need a tool like Synapse, but also if you want to work with big data and doing some analytics, Spark is something that will help you out. Okay. Then to support all of that, and that's why we're going to talk about the storage. Azure Data Lake storage is here to support and is going to actually be the storage solution for your Synapse. So you need, in a certain way, a data lake storage when you use Azure Synapse Analytics. This is something mandatory you need. Okay, and we're going to see that actually in the later module. About the languages that you're going to actually use for working with those modules are already languages that has been in the industry. So SQL, Python, .NET, Java, Scala, and the common line interface like the PowerShell, Cloud Shell, etc. So lots of libraries, for example, in Python are going to be used with Spark, for instance, for big data analytics, right? All those capabilities that you can see here, artificial intelligence, machine learning, Internet of Things, intelligent apps, business intelligence, are the things that you're gonna be actually using within Azure Synapse. That's why Azure Synapse is providing you a solution for data warehousing, big data analytics mainly. And then you're gonna also have the ETL solution with, for instance, Synapse pipelines, right? So it's a really like all-in-one solution. Synapse is a big platform where you're gonna be able to do anything regarding the capabilities you can see here with data warehouse, big data analytics, providing those ETL tools or ELT based on and always supported by the data lake storage. A data lake is a very, very important part in our data engineering solution since it's gonna contain in an efficient manner any kind of data we want to work with. Okay. And this is another perspective of describing Azure Synapse Analytics. Okay. Azure Synapse is made of many modules, many, let's say, things that in together are Synapse. It's quite a complex architecture in Synapse. It's not one, let's say, software module that allows you to do with certain features. It's a very complex, let's say, a platform for many purposes. So that's why you need to actually take out from what you're looking for. You have to start by thinking what do I need from Synapse, not in other way around, like what can I do with Synapse? Because if you try to know what you can do with Synapse, believe me, you're gonna get lost because it's so complex. It gives you so many possibilities that this way of approaching Synapse is too complicated or too complex. You could do so, but it would take you a long time to really assimilate everything that Synapse can do for you. So, at a high level, definitely it's always interesting to see what Synapse is made of and what it can do for you. So, as I mentioned, you have here your whole platform. And first, I talked about, remember, Synapse SQL and Synapse Spark, because those are modules or those are capabilities very commonly used, used within many use case. Our customers in Microsoft are actually using a lot of those two capabilities, the SQL pools and Spark pools. And again, that's for data warehousing and leveraging also the pipelines for the ETL process. And it's very, should I mention here quickly, similar to Azure Data Factory for those who are already familiarized with another solution component within Azure ecosystem. So if you know Azure Data Factory, you will definitely know how to work with Synapse pipelines. It's very similar, very familiar. The interface, the way of creating your pipelines. And Synapse Link will provide you the way of working with batch and the data flow, the streaming data, right? Data streaming with functional and analytical context, right? So both context in one and being, let's say, synchronized, because still keeping this ACID requirements when it is atomic, constraint, and so on and so on. All right. So we'll not get now into the details of all those modules, but just for you to know what it implies, all those modules. And Synapse Studio is basically the entrance, right? This is the door, let's say, the door to go into those capabilities that Synapse gives you. Studios is a very handful GUI portal, and when you're gonna perform all your tasks, okay? So that's the one you're gonna use and to enter into Synapse when you want to perform. Obviously, you have other way of performing Synapse features or tasks within the CLI, for instance, interface with command and automate your tasks. But when you want to learn Synapse, definitely Synapse Studio is a very handful way to do that. So let's get into the first capability of Synapse, building a modern data warehousing pattern. Okay, and here you just have to know that you have two ways of using Synapse, right? As I already explained, you can either build from scratch, okay? Build from scratch your solution, your let's say data solution. So that's one way of using signups, and it's gonna be one place for all, which is very, let's say, a comfortable or useful way of having your architecture. Or if your company or organization already invested into the data architecture with over components, over solutions, then you can still integrate Synapse, this architecture, the existent, the existent architecture. So Synapse is very, very, let's say, flexible, because here you have this overview, like the data sources you might consider and having already implemented or connected to. Remember, within your flow, you're gonna have to ingest and prep your data. So in this part, you can whether use Synapse or you can still use what you have implemented before, like Azure Data Factory or Azure Databricks, using an Azure Data Lake storage. And then you can whether use your Azure Synapse Analytics and finally visualize what you are actually here collecting. So that's the point here, the key point here you have to take out, like integrating Synapse into what you have already or to build something from scratch. That's the powerful, that's the power of Synapse. That's maybe why Microsoft called it Synapse, because the synapse, like in a brain, the word comes from this brain element, right? When it connects your neurons, and the synapse is something that's actually connecting. So here's the same thing here. We are just connecting components of your data architecture, and in whenever stages you are, like in ingesting part, modeling part, or visualization part. Synapse is that flexible. You can use it for ingesting, for modeling, and even supporting the visualization, because from Synapse, you can even launch Power BI. Okay, that's something possible. Perfect. So this is something important to know about Synapse. At this point, I've just gave you here a high-level view. What Synapse can do for you? Why should you use it for data warehousing, big data analytics, and some ETL solutions, and also supporting these hybrid transactional and analytical contexts, right? When you need to have a hybrid solution. Another component of the Azure ecosystem data engineering is Azure Databricks. That's what we're gonna try to describe here. And it begins here with some questions, like, well, not questions, but what would be how could you actually describe Apache Spark-based analytics platform? Okay, because that's one thing that Azure Databricks is, well, built from. And remember what I said to you when I mentioned Apache Spark is big data. Okay, so Databricks is actually done for big data. So why Spark based? Because it simplifies the provisioning and collaboration. Okay, and we're gonna here have now whether we want to deal with our data with batch or streaming data. So again, I'm gonna try to give you a quick crash explanation about batch and streaming data. Batch is, as it says, batch, you have your batch of data or like a group of data here waiting to be processed, right? But you first have to accumulate a certain amount of data, right, from your data source. So you creating your batch here, okay? And from there, you're gonna process that at some point. It can be, for instance, a very typical manner to do that is after the hours low, let's say, hours that your system is not used so much. So for instance, like midnight, at midnight you launch, you batch, and you process it. On the other way, streaming data are data that are processed straight away from your data source, right? Processed on the real time or near real time. And it's a it's a big difference. It's a big difference when you are working within a batch context or near real time processing. Okay, so Azure Databricks will be able to do that with your big data. So you will have comprehensive Spark library to actually work and try to perform machine learning capabilities. Especially in this course, you're gonna have a view in your labs. You're gonna work with a hyperspace library. Should I mention data frames? It's a very important library within Python. And Databricks have obviously security requirements. That's what we're gonna talk about. And we're gonna try to also see how you can integrate Databricks within your Azure ecosystem. Apache Spark said something that would provide you capabilities to perform data analysis, work with streaming analytics, and finally provide you any capability within the machine learning. What that means, trying to find some patterns, right? For instance, we talked a lot about machine learning, but what we try to do here is to find out patterns so we can predict later on what's going on, what will happen, and what should we do about that, right? There is a kind of analytics which is called predictive analytics and prescriptive analytics. Those two kind of analytics are answering the question, what will happen and what should we do about that? So that's what actually Apache Spark are supposed to help us when you use Databricks. So Databricks is really used by data scientists when you want to do some machine learning stuff and when you are processing streaming, data streaming, right? Kafka and Flume are something very similar. It's actually the same thing as Azure data streaming, right? The one that helps you and get your data streaming, right? Streaming analytics. Those are actually the tool that gives you the possibility of having a streaming analytics, right? So you get the data on the real time or near real time, and you process that, and you can actually kind of having some predictive analytics there. So yeah, if you already have some knowledge about Apache Spark, Databricks is actually a kind of wrapper. It's a wrapper around this technology. And more than that, it's gonna give you a simplification. It's gonna simplify you the life by configuring Spark cluster with a GUI interface. A GUI interface is very maybe more easy to manipulate at the beginning, to have configured your clusters. And a Spark cluster is used basically to process. it's compute. It computes any let's say data that you need to get your patterns to yeah, to identify the patterns you're gonna try to find out within your machine learning tasks. Okay, so yeah, remember that Databricks is built on Apache Spark, which is used for big data analytics, especially in machine learning. And you're gonna have interfaces that's gonna help you out to make your life easier to work within this field, and especially to collaborate. Okay, because it's gonna take you, it's gonna give you many capabilities. It doesn't matter if you don't know how to, if you don't have the developer abilities, developer skills to manipulate with just Python, with just Java or any programming tools, programming languages. But it's gonna give you an interface, a GUI interface to manipulate and do those machine learning and any big data analytics. And finally, we have to talk about the security part. So three different part, three different way to secure our environment. It's gonna leverage Azure Active Directory. If you haven't heard about the Active Directory within Microsoft ecosystem, just take out that Active Directory is like kind of a big book when you're gonna actually specify whether you can access to the resource or not. And now Azure Active Directory is, let's say, this very same concept, but at the Azure ecosystem level. So whenever you sign with your Azure Active Directory credentials, you will already have those security credentials to sign in, for instance, with Azure Databricks or any other component of Azure ecosystem. You have something also called RBAC for role-based access control. So it's the same thing, but based on roles, like which role do you have? And over there, it should be specified and of course, signed. And then you have the enterprise service level agreements, and that's something about a requirement about which kind of quality you are expecting your solution is actually performing. You might have already heard about the SLA term within other, let's say, context. And here's the same, right? You are expecting some kind of level of quality. So yes, you can integrate Databricks also with many other components of the cloud ecosystem of Microsoft. So your Data Lake, Cosmos DB, which is a NoSQL database, Data Factory if you're using already an ETL tool, Power BI as a data visualization, Azure Synapse Analytics, already talked about, and Blob Store, which is actually the let's say data lake similar storage component, because a data lake is actually based on the Blob Store. Okay, but that's something we're gonna see later on. Cognitive services, when you are making data scientist tasks and you are looking for patterns with machine learning, deep learning, etc. This is a quick way of giving you here a big, let's say, resume or an overview about the different type of Spark technologies you have within, for instance, Apache Spark, which is the, let's say, the standard, the basis. Apache Spark is the one that has been built first. You have the derivation or what has been therefore to complete, because any open source solution, remember, can be reused and commercialized well under licenses for any other product. So Spark has been definitely implemented within the commercial version of, for instance, HD Insight, which is another component of Azure ecosystem, Azure Databricks, and Synapse. Okay, it just explains you the differences. For instance, why to use Apache Spark or why should you use rather Azure Databricks. For instance, here it provides you the ability to create and manage an end-to-end big data science project using just one platform. Okay. Here in this case, is more about data warehousing. Remember, Synapse, data warehouse, Databricks, data science, big data analytics. HD Insight, same thing, but it can take an advantage of other things like OSS, but I will not talk about deeply about more of those concepts. And especially if you are concerned with the service level agreement, then use HD Insight. Okay. I will not dwell on this table, but just to give you the knowledge that you have different kind of Spark, okay, different implementation of Spark, which is a technology to work with big data. And it is open source with Apache, but within Azure ecosystem, you're gonna have this, let's say, a different sort of or different implementation of Spark, HD Insight, Databricks, or Synapse. They are implementing Spark in a different way for their different needs, let's say. Now, let's talk about the Azure Data Lake storage. Okay, this is a very fundamental thing here because all your, let's say, architecture will actually be underlined with this data lake storage. And within the process of big data, and that just not in Microsoft ecosystem, it is actually valid for any other big data ecosystem. You have 4 stages. First, the ingestion. Okay, the data comes from files, logs, any type of unstructured data. It's gonna be put, in this case, in the data lake store. Okay, so that's the first step in your big data process. Then, when you get this data from any kind of source, you store it, as I said, in the data lake store. And in this case, here we're gonna talk about Azure Data Lake Storage Generation 2. Data Lake Storage. And I'm gonna put here Gen 2 because you have Data Lake Storage Generation 1, which is different from the Generation 2 because Generation 2 have a hierarchical namespace. That's the difference with the Generation 1. Hierarchical namespace. So you will be able actually to put some hierarchy within your storage. So it's not going to be flat as it was in the first generation. And the paradigm is changing actually. So that's why it's going to be more efficient for you big data analytics, or whether it is data warehousing. And finally, and talking about data warehouse, here we go, model and serve. That's where actually your data warehouse comes into the play. Or if you do data analytics, sorry, big data analytics, yeah. So that's where you're gonna actually put your models. You're gonna actually, sorry, I was talking about too much, too too fast. We have the prep and train phase before, just before here. So the prep and train, actually you are modeling and training your data, and this is very, very common within actually here, big data analytics, because you are trying to find out some, let's say models, let's say the patterns, and those patterns are helping, right? What will happen in the future, and how should you handle those situations? So, which is prescriptive, right? So that's what happening in this stage, right? And especially what we have just seen right now, the Azure Data Bricks goes there. Azure Data Bricks for prep and training. Finally, for modeling and serving, as I said, that's where you're gonna actually use here, whether it is Synapse and Power BI. Power BI is a very powerful tool to visualize data and to build its own model, its own little data warehouse, let's say, because you are modeling data over there, like also with a star schema, with your fact table, dimension tables. So that's where you're gonna there in the fourth stage, modeling and serving data. But Synapse is actually more powerful than Power BI when you're dealing with a huge amount of data, right? So it really depends on your needs, actually. What are your needs? What capacity you need in terms of the storage, the amount of data. If you are very into the big data, Synapse is gonna be definitely mandatory to model. If not, Power BI can be just enough, and you just get the data from the store that you have here, or even sometimes from the data source. So that really depends. But in our case, you just have to be aware that both, let's say, possibility. You use Synapse when you need big data warehouse, so you have a SQL dedicated pool for that purpose. And for preparation training, you use Azure Databricks. Now, supporting all those capabilities, remember I told you you have your Azure Data Lake storage. Why? Because it's going to be Hadoop compatible. Hadoop is a way of structuring your files within a distributed architecture. And remember, or let's say to give you here, what is it, or why do you have an architecture which is distributed with nodes, clusters? It's because of big data again. Big data makes it very or impossible to handle with just, let's say, one machine, one computer, because it's too big, it's too huge. So you need to have many, many, many computers working all together, which are called clusters. And that's where Hadoop was created, actually in Berkeley University, if I'm not wrong. Over there, they're actually developed or designed an architecture capable of handling these big data needs. And if it is Hadoop compatible, then it's great because you're gonna be able to leverage what is already in place or to be connecting to this solution. It's gonna provide also security requirements. So everything in a secure environment. It's gonna be performant because remember we're gonna talk about the second generation, and redundant. Why redundant? For those who are not so familiar with the, let's say, network requirements or let's say data requirements, your data, as you may have already heard about, on the servers have to be backed up and saved, etc., etc. And even in the Azure ecosystem, you need to check out what about the redundancy, like geographically where you want to have your data stored, replicated, because of, let's say, security concerns. If something happened on one data center or on the server where your data are, well, if you lost them, then it's a big concern, right? So always your data has to be redundant. So that means replicated in many other places. And so they are available, right? So here is an example of how it looks like with creating a storage account within the Azure portal. So as soon as you have performed your basics uh, configurations, you go in the advanced for creating a storage account. That's where it begins. You create a storage account, and in the advanced options, you're gonna have something here where it's gonna actually be able to convert your storage account into a data lake storage generation 2. Okay, your data lake will be generation 2 if you if you enable, sorry, the hierarchical namespace. Okay, you have just to enable that to make it a data lake storage generation 2. Okay, that's the way you create your data lake storage generation 2. When you create your storage account within the Azure portal. Because the data lake store generation 2 is based on the Azure blob, right? But with this hierarchy space. And here is the difference. An Azure blob has this just flat hierarchy when you have your data, right? Actually, the blue dots represent a different type of data, whereas the black dots represent the root or parent folder in the hierarchy. So you have here a hierarchy. That's where when you're gonna look for the computing, let's say nodes are gonna check out the hierarchy to get the data. For big data use cases, I'm just mentioning here quickly those 3 use cases. I will not get into the data because you're going to actually see that in the next modules. So building a modern data warehouse is something that you definitely need when you work with big data. And then Azure Synapse and Databricks are actually very good in that sense to use together or just one of those 2 components. Advanced analytics is definitely a use case for your big data. Databricks is the one designed for with based on the Sparks technology, and also the real-time analytics. And again, real-time analytics, just one example as a use case when, for instance, you are working with a company that actually provide you some smart devices, and those smart devices are actually giving you are generating some data in real time. For instance, some robots, cleaning robots, those cleaning robots actually I bought recently, and they're continuously providing data and sending it to the cloud, and they should be processed. And in some way, you have to monitor those data, right? And take some actions, some decisions has to be made. So that's where, for instance, it's a good use case in a real-time, let's say, analytics. Now, we're gonna move on with describing the data lake architecture. A data lake architecture is, as I said, not a service, but a format. That's something you should remember here and take out from that. It's not a service, but it's a format. Many confusion about that concept of data lake architecture, right? So it provides you the, let's say, possibility to manage streaming data and batch data, right? So you have those two, let's say, flow, and I'm saying like flow, you are processing the data. In the streaming, remember streaming means like it's on the real time. It get the data are coming continuously without any interruption. And with batch, you are processing now and then some batch. So for instance, every day at midnight, or every day at 12 o'clock, etc., or every week. So the processing time from the both flow here are different. However, we're gonna have them formatted into different tables here, but consistent in a consistent manner. And you're gonna have three levels of those, let's say, organization of your data here. First, you're gonna have just the tables that are ingesting the data from the both flow. And they are just raw data without any specific organization, any specific, let's say, yeah, way of putting those data. They are just raw data over there, and no transformations, nothing has been done on those data. So that's why it's bronze, the first one. The second level, we have performed some actions on those tables. We have, for instance, combined tables. We have uh, joined tables together because we organize them a bit more. So that's why it's called refined tables, and it's on a silver level. And finally, and that's where you're gonna actually perform some transformations, some cleansing, like in the ETL process. Here you're gonna have tables that are some aggregated data, for instance, by year, by customers, by products, something that makes more sense. And there you can get some insight. And that's the gold level, right, into your data lake architecture. Remember, you have those three levels all together, getting from to those two flow of data, batch and streaming. And that's your organized, let's say, data within an Azure Data Lake storage. Okay. I know it's a bit maybe complex at the beginning to think all about those concepts, but just think in that way, in the high level way. You have two flow of data, batch and streaming, and you're gonna organize your data here in three different levels. First level, raw, you don't do anything on them. Then you start to combine some data roughly, and finally you're gonna aggregate, you're gonna clean more, etc. So you have here your data ready to use, ready to visualize. And that's what is a data lake architecture. Okay, it's a more advanced architecture of what we call the lambda architecture, and you will actually see more about this concept here, lambda, in I guess in the lab or in the, for instance, learning path on Microsoft web page. You can have more detail about this concept here. And finally, let's have a word about how you work with data streams, stream analytics. So, as I mentioned previously, data streams analytics are streams, are events generated by, for instance, sensors or any other sources, and are gonna be analyzed by some technology we're gonna use here. Right? So, two different approaches. You have the reference data, collect those data over time, and it's gonna be stored in the static way. In contrast, you have the streaming data. The requirements about the storage is quite low, and you're gonna use, for instance, sliding windows to visualize them, to work with them. So you're gonna use windowing. Um, there are used actually to analyze data. That's the use cases here. Understand systems or trigger action. So give you some examples. For instance, you are an owner, or not an owner, but you're working as a data engineer for e-commerce, for an e-commerce business, and so you want to check out what's going on, like Amazon. Amazon wants to know what are the products currently at the top, right? Or how the user are actually what's the behavior, should I say? What's the behavior on your web page? And that's going to be very good way of data streams. You want to analyze where the click has been done, etc. So you want to analyze all those things that are coming in the stream. Then you want to understand systems. Like for instance, you are analyzing a big complex system, and there are some behavior done. There are going to be some some log files, and you need to get those logs in a real time, because you need to get those data right now and getting all the insights on the real time. Same thing when you want to trigger some actions, right? So when the requirements are actually strong and it concerns there are huge risks in the business. We can talk about, for instance, even the project where you are talking about human lives, for instance, in the aeronautics space, when you need to trigger actions on the fly right now, then you need to work with data streams. Then you will actually see in the future modules something called event hubs. Event hubs is a component of Azure ecosystem where you can actually collect any events from an event producer. So let's say a smart device. Your smart device is producing data, okay, like a sensor, and it's going to generate it continuously. So you have to get those events or data generated, like from a heart rate monitor, a highway to, and this event app is going to get those data and it's going to process it. Okay. And it's going to process in a different way. So that's where windowing, when I mentioned, is going to come into the play. So they're going to be different type of context, right? Problem space, one incoming event at a time, or process multiple events at a time. So that depends on what you are monitoring. Finally, you're going to have to consume. You're going to consume those events generated after being processed, right? And therefore, you're going to be able to take some specific action, because you're going to get the insights for those events generated, or even you're going to send those data to another event processing engine. So this is the free component here about data streaming. Some things has to produce the data, then you're going to process those data, and then you're going to consume those data. And that's what is actually being done with Azure Stream Analytics. You have a source, you're going to ingest, you're going to analyze with an engine, and finally you're going to direct or get into your data lake or any other database, like a Cosmos database or SQL database, or just a blob store, or even being ready to be in Power BI. The language or the framework available within Stream Analytics are .NET and the query language like SQL. But ingesting you have it from the event hubs, as I mentioned, or an IoT hubs, Internet of Things hubs, right? And it can even take those, let's say, data stored already in the Azure Blob Store. So here you have the schema, how it works, like from the event hubs or from a blob, takes that on the event producer, complex or even processed, the complex event processor is going to process those data, finally to be consumed from another, for instance, way of even hubs, or to store that, or to get that into database or visualizing that. Okay, Azure Stream Analytics is actually getting that process for you in also very efficient manner, because it's in a GUI. Azure Streams as a GUI interface, so you can actually manage all those three, let's say, phases in a very easy fashion. Now comes the questions part, and you can answer that on the chat. So Azure Synapse Analytics offers Synapse SQL in two offerings. Remember at the beginning when I was talking about Synapse, when you have your data warehouse and you can whether leverage something with a pool, and those two type of pools, what those two type of pools were? That's the question here. So I'm gonna give you 5 more seconds. And data set, open row set. Open row set is actually a function of the SQL, pool, when you can actually get your first rows, right? About, well, not just the first rows, but you can open the rows about your data source, right? So it's part of this T-SQL, let's say, but the type of pool that you have here, or whether dedicated SQL or serverless SQL pools. The difference is you here are provisioning a pool of SQL, right, the SQL pool, and here you're not provisioning anything. So yes, Spark Pool, actually somebody here is mentioning also Spark Pools, is a bit different from Synapse SQL. We just talked about the Spark Pool instead of SQL Pool. But when you talk about SQL Pool, you just are referring to the dedicated or serverless SQL Pool. And as I was mentioning, difference is dedicated, and you are provisioning, you are actually taking care about something when you want to predict, when you have something very, very more fixed thing about your data warehouse. You know how much space you need, you know how much of computing capability you need. Whereas in serverless, you're just using in ad hoc queries. You are just, let's say, getting what you need. Serverless is actually kind of a very, very, very extreme platform as a service, or even software as a service, where because you just pay for what you use, nothing more, nothing less. Whereas here, in the dedicated, you are already provisioning something. In the serverless, you are actually getting the data, what you need, and you're just paying, or you are charged for what you are really asking here. That's one quick way about defining, let's say, serverless. It's a quite tricky concept, serverless, because many topics goes on this serverless, on this concept. But you will understand little by little when you're gonna use these serverless capabilities from SQL Pool. Now, which Azure storage account option must be enabled to optimize the storage account as an Azure Data Lake for analytical workloads. And that's something I insisted a bit when we were seeing the configuration. So yes, the answer was hierarchical namespace. Remember, actually, a data lake is based on the blob storage, as simple as that. And the blob storage is a container to get your data over there, files or anything that you want to put in. But here, what makes a data lake is hierarchical namespace, and especially data lake generation 2. That's why it's compatible with Hadoop and so on. But yeah, you need to make the hierarchical namespace on there. And finally, which architecture enriches data through unified pipeline that allows you to combine batch and streaming workflows. Remember this architecture I was talking about when there are two flow getting from batch and streaming, and then you're gonna process them. And I see some answers here, many. Yeah, data lake architecture. Okay, and you're definitely right. Lambda. Okay, yeah, Lambda is the one that's just been developed previously, but data lake is the current one we want to use, and more are using actually this architecture when you want to unify with a pipeline, batch, and streaming workflows. In a couple of minutes after, at the end, we're gonna first see the module 2, and then you will have the opportunity to explore compute and storage options within a lab. So it's gonna be maybe more bit clearer for you guys, putting in practice, hands-on practice about the concept I've just explained. So without any further ado, I will close and wrap up this module and begin the module 2, because here, yes, we have seen a couple of fundamental things like Synapse Analytics, uh, Synapse. We have seen Databricks. We have seen these data lake storage options. And we have seen data lake, Delta Lake architecture. So that's what you need to think about and try to remember about this first module. All right. Uh, those four components, those four themes are very important and fundamental. And during the labs, you try to check out and see some capabilities about those four domain. All right, so yes, let's go and that's for the lab review, but you will see that later on. So again, this is the summary, data lake, Synapse, Databricks, Arc Data Lake, and the stream analytics also, okay? The stream analytics when you need to analyze data in real time. Okay, so let me launch the second module here. So give you just 1 minute of break. And yes, the second module is run interactive queries using Azure Synapse and serverless SQL pool. So now we're gonna get into one specific module, one specific, let's say, component of our data engineer Azure ecosystem, right? I mean, those five different themes that we have seen in the first module. We are now getting and diving into Synapse Analytics, and especially into the serverless SQL pool. Why serverless SQL pool, and why not dedicated? Because maybe serverless SQL pools is something very interesting, and some of people in the industry are actually saying or let's say, arguing that serverless would be in some way the future of our architecture. Let's say the orientation of our data architecture is serverless. It's a very, very important concept here, serverless. And at the first sight, you might think, oh, what does that really mean when you say serverless without any server? There's, we still need some machine behind our, let's say, computing. It's not possible to have no server. But what implies serverless is really like we don't own or we are not responsible. We are not responsible about configuring, about setting up the provisioning the server as per se. Like in a PaaS, the PaaS platform as a service, you are not actually entitled or responsible to all the infrastructure beneath your, let's say, data that you are setting up with your database, etc. So here is the same thing when you want to work quickly on the data and query, explore in a SQL manner your data in the pool, in your pool, right? That's why also we're talking about pools, not like a database management system, because the pool, the SQL pool, has a different paradigm than in the relational SQL database, a classical one. There's a couple of differences that exist between those two things. And what is interesting with serverless is you are actually focused on really what you are here for. You don't need to be worried about how you provision, how you set up the infrastructure to make it work. So that's why it's very interesting, the serverless. I hope this little introduction gives you a bit more insight about why we are here seeing the serverless SQL pool. And we are in Synapse, right? Remember, we are within the Azure Synapse. We're going to see how to query data. It's always in the lake, in the data lake, right? And how to create metadata objects, because this creation, those metadata are gonna actually help us to give, let's say, it's gonna be easier for any other module or any other component to look for data in your, let's say, SQL pool. So creating metadata is very crucial when you want to be efficient. And finally, we're going to see the security aspect of your data, how to manage users. So let's go on with the first thing, exploring data. And it says, every Azure Synapse Analytics workspace comes with the serverless SQL pool endpoints. Because, as I said again, you don't have to provision anything. So that's why it's already available. As soon as you create, and we're going to see that how to create a workspace within an Azure Synapse Analytics, that's the first thing you should do when you install or when you get a Synapse Analytics within your subscription. You need, first of all, get your workspace. And when you get your workspace done, then you can start straight away with the server SQL pool. It's going to be available right now. And therefore, you're going to be able to query straight away your data. Imagine, in seconds to minutes, a data lake. When we've over more classical architecture, which are not serverless, it's not possible to do that in a matter of seconds or minutes. You have first to provision a server, to define a couple of things to be able to query your data. And as I said, no infrastructure to set up or clusters to maintain. Even if you're not so familiarized or if you don't know what it is about here, like what's about this infrastructure, how do you usually set up an infrastructure, how do you maintain a cluster, it doesn't matter. You just have to remember that here there is a big chunk of workload here to do, then you don't have to do that. The comparison is quite straightforward. Since in a dedicated SQL pools, usually you do that with data warehouse operations when you know and you have to get the control about the let's say the workload, yeah, and you want to be sure of how much Microsoft Azure is going to charge you for maintaining your data warehouse. You can use a dedicated SQL pool because you're going to provision exactly the capacity, the memory for it. Whereas here, you just use it for some ad hoc queries, which means some casual queries with some unstructured data. So that means you don't know yet how much of capability of computing or memory you need. The serverless will take what it needs to get your query done, no more, no less. So here is more predictable, yes. Whereas here with the serverless, you're gonna find out at the end how much you needed to provide your to provision your workload, how much you needed to get that query done. But still, you can actually predict more or less what kind of queries are gonna be very high workloading or not. Finally, here you are reserving processing power for your data, whereas here it enables you for interactive query. So yeah, just getting into the main titles here, not getting into the details, because anyway, you're gonna see that in lab and in the future modules. So you have the possibility of exploring your data when you use your actually the serverless SQL pool. You're gonna be able to transform your data, and finally, you're gonna be able to create some logical data warehouse and create views for external tables when you need external tables. And when those objects are created, you can connect that to any server SQL pool, and they're gonna see that as a regular object, as a regular SQL Server object, which is very useful when you're gonna actually use Azure SQL databases or Cosmos DB, etc. So any work you're gonna perform within the server's SQL pool are gonna be able to be reused and are gonna be some way persistent with over, let's say, workload, right? So explore, transform, and doing data warehousing, should I say, is possible within a serverless SQL pool. That's what makes actually a serverless SQL pool very powerful and very. That's why we begin with this module with a serverless SQL pool. So yeah, querying data in Lake using Azure Synapse, the serverless SQL pool. The common files you can query within a SQL pool are gonna be with a Parquet extension. Parquet is a column-wide, column-oriented files, right? Its data are actually structured in the type of column, right, which is really efficient for analytical workload. And you have also the ability to query JSON, what we're going to see here, JSON files and any delimited text files like CSV or any flat files on the same CSV types, right? JSON is more and more commonly present, like you are getting into the websites and any API are usually getting the data in the JSON format. The JSON is like, let's say, key per value, like you have a value, try to get it here. You have like a, let's say, attribute, and then you have a value for that attribute, right? And then you're gonna have over attribute, and then gonna get another, sorry, get another value. And you will even be able to define some, let's say, hierarchy between those attribute value curve, right? So that's the way a JSON document is structured. Uh, just having some attribute value. Not all of the instances of a JSON document are having the same attribute, like in a SQL database. Remember, in the SQL database, you have always one value for each column. It's not the case in a JSON document. So, for instance, to give you a very concrete example, is like my client number one has an email address, but my client number two doesn't have any email address, so I don't have any attribute for this uh, client. But for instance, a phone number or even a fixed phone number or any other way of reaching this client. So that's why a JSON document is very, very useful when you have different type of data. You are not sure, you don't have the same data for every instances, right, of your, for instance, database. Now, remember I told you to use Synapse. You go to Studio. You go to your Azure Synapse Studio, and that's where you're gonna be able to perform your actions and use your features about the Synapse. So here is how you can, for instance, check out and explore, do a very quick exploration within your data, and selecting, it's a very, very common thing to do, selecting the top 100 rows in your file, whereas it's a Pocket file or CSV, etc. So to do that, you go on your Synapse Studio and you're gonna see here on your left panel, workspace and linked. So you clicked on linked, and then you're gonna explore within your data lake which storage, where blob storage you want to use. Right? For instance, here we chose Azure Workspace XX12, right? And within this blob storage, you're gonna have over, let's say, subfolders. So you're gonna pick the one you are interested in, and then you're gonna see here the hierarchy. Remember, our data lake storage generation 2 has a hierarchy, so that's where it appears here. You go into this hierarchy, you check out, you take out the, you take the file that you want to explore. And in this case, it's called cell hyphen small hyphen 2019 because it's in the year 2019. It's in the month December 31st. Snappy.parquet, so it's a Parquet file. Selecting it, you're gonna be able to right click on that and having some contextual menu here, and you have some actions. So you want a new SQL script, and as a new SQL script, you're gonna, for instance, here choose select top 100 rows, right? So that's one way of, for instance, explore your data very quickly. You see, I haven't even had to type any code because I don't know how to code, for instance, in T-SQL. Who knows T-SQL here? Maybe all of you, maybe some of you, but you don't have to. And that's why Synapse Studio is actually makes your life easier, whether the data engineer is familiarized or has some ability, some skills with programming with using SQL, but you don't have to in this case here. It's always better to know SQL, but the GUI interface here allows you to make this query without even typing any word of SQL. Here is the way of, for instance, querying the Pocket file, but here with the T-SQL. So that's the way it looks like. So make sure that you are connected in the building because we're on a serverless SQL pool. So it has to be here chosen built in. Now we are selecting the top 100 rows, right? Stars, so that means any column from, and now somebody mentioned previously open row set. So yeah, that's a function within T-SQL that allows you to open your file here at this address, bulk, and then you provide the address of your data lake storage where the file is actually located. So here is, for instance, the data lake storage address, DFS, corewindows.net slash, and then you have here your path where this file is. And the hierarchy is appearing here actually. Year 2016, quarter Q4. You have to specify how the format is of your file, park it with the code, and finally we close the parentheses as result. That's how was actually presented the T-SQL for querying the your data in the data lake with some files, which can be Parquet, which can be CSV or JSON. Those are the three common files you're gonna work with, especially in the labs that you're gonna have access to. Now, create metadata objects is a very important thing because metadata objects helps you to query data and even optimize your existing data, especially if you do pipeline transformation, for instance, and you use Synapse serverless SQL pools. So it's gonna enable any other clients when they're gonna connect to the serverless SQL pool and they wanted to discover what data are there. So these objects are gonna be able to query the data in this lake. So this essentially creates a semantic layer, let's say those metadata, a semantic layer. Therefore, it's make it easier to get the data that you're looking for, right? For instance, for some tools like Power BI, and Power BI would be able to consume the data easier. So first here, you should start by creating a database, right? And then you can create other things that we're gonna see here. So creating database are here, for instance, the way you can specify that with a SQL language, create database, and then you put your name with those brackets. So here you go. For instance, you have create database with some scooped credential. This is required to provide access to external objects, such as blob store. Okay, so you have to provide here identity because you have some security layer with some secret, and you provide here the secret, for instance. You have create external data source. Okay, and this provides the connection information to the data store in the form of a URL and makes reference to the database scooped credential that is used to authenticate the access to the data store. Then you have create external file format, and this is going to provide information pertaining to the format of the files that will be accessed within the data store. Okay. Whoops, sorry, I have been a bit quick here. And finally, yeah, you have create external table. And this contains basically the table definition in which the data from the file will be loaded into. Okay, so those are basically the actions you're gonna need to do when you want to create metadata objects. Okay, external data source, scoped credentials, the file format, and some external tables. So finally, let's wrap up this lesson, this module with the securing data, and managing users within Synapse for serverless SQL pools. So three areas to consider when you're gonna work with security in Azure Synapse Analytics, serverless SQL pools. Authentication. So authentication, that's the process of, let's say, proving the user who is who. I mean, you claim to be this user, so yes, that's the way of proving that. So you're gonna connect to database using a user account, okay? And you are providing here a user account and let's say of an authentication information. Okay. Then you have authorization. Authorization refers to the permissions you are assigned as a user, and it's gonna actually determine what you can do, what you are allowed to do. So that's two different things here. Here you are proving who you are, whereas in authorization you are, what can I do as this user? Who am I? What can I do? And finally, accessing this storage account. Um, yeah, you can access the storage account, and as the storage is creating files, okay, that are stored in the data lake, there also has to be consideration for data lake security as well as Synapse Analytics security. Okay, so that's where you're going to access the storage account, because you can here specify what you can do, but here what storage accounts you can access, what you can actually see, read, write, etc. So yeah, let's say two two layers of security here about authentication and authorization, very important. Okay, that's the two main important one here: authentication, and it's actually present in many components of Azure ecosystem. Okay, it's no different. If you know already the Azure ecosystem within other, let's say, domain, or you have already studied other components of Azure ecosystem, you should be actually familiarized with those two concepts. And the third one, to access the storage account. So here goes a bit more about what we just talked about, like authentication method, right? So you authenticate it to the dedicated SQL pool, and you can do that with a SQL authentication, or you can use your Azure Active Directory authentication. And therefore, you'll be able to get access to data lake store. You have different options like anonymous access, the shared access signature. Uh, the shared access signature is good, but it gives you many possibilities. So it's actually a good way to give access to users with not so much, on the contrary, not so much, let's say, uh, possible. The shared access signature is a very good option. Managed identity and user identity, right? So those are the identity you can over there manage, who are using what and what they can use. So how to manage users in Azure Synapse Serverless SQL pools? Um, well, the second part of the lab actually will show you what about the authentication and authorization, right? You're gonna perform work action on those accounts. So um, authorization to access data and actions and managing those roles is basically to determine what the user is allowed to do, right? You're gonna define role and the object level permissions. So what role are gonna be created over there? So for instance, I'm a manager, I'm a data engineer, I'm a data analyst, and you're gonna assign the permission to those roles, okay? And therefore, you're gonna have the storage account name. So you're gonna be able to assign those roles to a storage account name. For instance, in this case, Azure Data Lake in date 84, for instance. So that's the way the users and the roles are actually managed. So you define roles, and therefore you're gonna assign for those roles what storage account they have access to. Here we go. This is how it looks like. You go on the storage account, right? You then click and you find, you go and find the containers you are looking for. And over there, you're gonna get into the hierarchy. For instance, let's say you want to provide some managing, so you want to manage the access for the year 2019. So you're gonna right click there and manage access. And then you provide the roles over there, which one would be able to access. Question times, people. Okay, which SQL function enables you to access files in Azure storage and read the contents of a remote data source? I'm gonna give you just 1 minute to think about. And the answer is open role set. Hey, that's one actually, one function that has been mentioned by somebody in the previous question. But this is a function, a SQL function. And as I mentioned, this function, this powerful function, makes you available or enables you to get into the file and read the content. And yeah, I got here answers from you guys. Perfect. Open role set. Yeah. Second question, which metadata object allows you to reuse the queries that you create, enable applications to view data in a serverless SQL pool? So there's an object that allows you to reuse queries, and I mentioned it very quickly, but yeah, don't worry. You're gonna still have opportunity to train on the learning path all those concepts that have been mentioned here. And a view as in a relational database is very useful to do that. You are creating a query, you want to reuse this query. Instead of rewriting this query again and again and again, use a view. And using the view is like a shortcut. You're creating something and you want to use it, a view is perfect for that. Finally, name the free permissions that can be set on the container object. Free permissions set on the container object. Read, write, and execute says data. Okay. View here. So no, okay, that was for the previous one. And the answer is yes, you were right, data. Right? Read, write, and execute. Definitely right. Perfect. All right, guys. So now we are done with the theoretical part. You will be able to go into your lab with your credential that you have been provided, and you're gonna actually, for this module, run some queries, explore data within Azure Synapse Analytics using the serverless SQL pool. And that's quite logical because it would take you a bit of more time if you use the dedicated SQL pools, since you will have to provision a server with the capabilities of computing and memory storage and everything. So the serverless one is actually a good use case in the lab. Use and quickly query, explore your data that you may have in a SQL pool as a data warehouse, for instance, or performing some big data analytics. So that would be for this module. For the previous module, you will be able to check out and understand a bit more about those components we have seen: Synapse, Databricks, Azure streaming, data streaming, Analytics, Streaming Analytics, sorry, and obviously the Azure Data Lake storage, right, and the Delta Azure Data Storage, the Data Lake, sorry, architecture. So that's the thing you're gonna see in the labs right now. And we're gonna have also a little break here, so you will get back into the labs in, let's say, half hour. Um, Wrapping up this module, yes, you have seen a couple of things to get into your data, to explore it with, for instance, three type of files. We have talked about markets, the CSV and JSON. We have talked about the data lake, where those files, how to query those things when it's going to be with T-SQL. But remember, with the Azure Portal GUI, the studio management of Synapse is quite easy to do that without even SQL statement. And finally, we have seen some security matters like logging in and getting into with the Azure Active Directory. You can use the role-based access control and the access control list. Right, so that's what we have done. Explore, query data, creating metadata, and security within Synapse serverless SQL pool. So we will get back in 30 minutes for the lab session, where our, let's say, experts will be helping you out with the connection and with setting up and any doubt and concerns within your labs session. I hope it was informative for you guys. Thank you very much for this, for your time, for your participation, and we'll be back in half hour.